All right, welcome back. We're going to be doing some partial fraction decompositions here for this problem right here. All right, so let me go ahead and go over that one. All right, so what do we have here? X squared plus 4 over, let's go ahead and, what's the denominator? 3x cubed plus 4x squared minus 4x. 3x cubed minus 4x squared plus 4x, I think. Or is that a minus? Did I get the signs wrong? I got them swapped. Let's make this one a plus and make this one a minus. Okay. So what we're looking for here is we're going to do partial fractions. And one of the things we have to do is we have to check the degree of the numerator and the denominator. If it's an improper fraction, right? If this was a 3, we would have to do polynomial division. Okay, your book does have a couple where you have to do this, but I decided that since this was a long problem to start off with, maybe we don't need to do a problem like that. Okay, but the next time you're going to need this, Calculus 2, they have some problems where they're the same. So just remember that, okay, 2 years or a year, remember that this is the case. All right. What we have to do here is we have to factor the bottom. Okay, so we're going to factor the denominator. All right, the denominator, right, we have 3x cubed plus 4x squared minus 4x. We're going to go say that's x. We have 3x squared plus 4x minus 4. Now, you can look at this and say, well, maybe I'll just try to factor it. You can always double check, right? You can always do, you can check the discriminant. Like, is it going to work? So discriminant is b squared minus 4ac. So that's 4 squared minus 4 times a is 3, c is negative 4. So that's 16 plus, right, 12 times 4 is 48. That's bigger than 0. We're going to have 2 solutions, which means in theory, this is factorable. Okay. It may not be nice, but it is factorable. Okay, great. Let's see. You could do guess and check. All right, I was taught that guess and check in high school, and that's how we did it, but I would not recommend it that way. I would recommend the AC method. Okay, that's AC method. Okay. What you're going to do is you're going to take the first number and the last number and multiply them together. So 3 times negative 4 is negative 12. And we're going to list out all of the factors that make up negative 12. Well, not all of them, but some of them. So notice that this is a positive 4. So the big number has to be positive and the little number has to be negative because they're going to add together. Okay, so if I'm going to add these together to get 4, right, it has to be positive. So big one has to be positive. So we have negative 2 and 6, negative 3 and 4. And those are our factors of 12. Okay, you don't have to list them all out. You could look at this one and say, wait a minute, 6 minus 2, that's 4. That's what I'm looking for. Okay. The next thing we're going to do is we're going to turn this 4 into a 6 minus 2. So we have 3x squared plus 6x minus 2x minus 4. Okay, you can technically put these in any order you'd like, but I tend to like to group like the 3 with the 3, right? 6 to the 3 times 2, and then the even ones together. So if there was a 5, I would want to put 5, 10, or 25, or whatever it was. I would want to put the 5s close together. Okay, because we're gonna factor by grouping now. So this is going to be 3x, right? And then we have x plus 2 minus 2, and we have x plus 2. So we're going to go ahead and factor out the x plus 2. So we have x plus 2, 3x minus 2. All right. So back to the beginning. So we have x squared plus 4 over x plus 2, 3x minus 2. And since these are all linear terms, they get a single constant on top. So this could be ax plus b, x plus 2 plus c, 3x minus 2. Okay. If you had an irreducible quadratic, right? You would have a dx plus e over an x squared plus some stuff, okay? If you had a repeated term, right? If it's a repeated linear term like this, you would just have like a d and then another one of these. A repeated term, I mean, is like there was a squared here, or cubed, or something. But this problem is going to be long enough, so we're not going to do any of that, okay? And that's one of the reasons why I didn't put all that stuff in there, because it's already big enough. All right, so the next thing we're going to do is we're going to solve this equation. Okay, so this is a rational equation. What's your first step with a rational equation? Turn it into something that is not a rational equation. All right, multiply by the common denominator on both sides. So this side, x squared plus 4 is equal. Now, when I take this whole mess and multiply it by a over x, these x's, right, they cancel. Okay. When I take this whole thing and it goes to visit b, right, goes to visit the middle term, the x plus 2's cancel, everything else is there. All right. When this mess goes to visit c, right, the 3x minus 2's cancel, everything else is there. Cx. Right. Now, for the people that are watching this that know that there's a shortcut, like, yes, there's a shortcut. For the people that don't know there's a shortcut, there's a shortcut. However, the problem that you have on your final, I don't believe works with the shortcut. So I'm going to go ahead and do this the long way so that you can see the full thing. Okay. So what we're going to do is we're going to say, well, I'm just going to swap them. The equal sign is going to be the x squared plus 4, and then I'm going to go ahead and do that. We're going to have an a, and I'm going to multiply these out together. So it's going to be 3x squared, right, minus 4x plus 4. Nope, minus 4. This is positive. That one's negative. All right, negative. And then we're going to have a plus b, and I'm going to multiply these together. So it's going to be 3x squared minus 2x plus c, x squared plus 2x. All right, just multiply everybody out, kept the coefficients in front. Why'd you do that? Because the next thing we're going to do is we're going to do something called equate the coefficients. Okay. Does it make sense that everything over here that has an x squared in it has to add up to 1x squared? And everything that is on the left-hand side with an x in it has to add up to 0 x's. And everything with a constant in it has to add up to 4. Okay, that's what I mean by equating the coefficients. So I go ahead and I make a column or rows. So we have 3a plus 3b, I think that's this one, plus c has to be 1. The x, right, we have 4 a's, okay, we have minus 2 b's, okay, and we have plus, looks like 2 c's, okay, that has to be 0. All right, last one, the constant, we have negative 4a, there isn't a constant, and that has to be 4. Okay, I think it's pretty safe to say that a is equal to negative 1 here. All right, now I would not want to solve 3 equations, 3 unknowns. That takes a long time to do. So if you are taking my final and you have taken this problem, you're like, oh my goodness, it's 3 equations, 3 unknowns, or 4 equations, 4 unknowns. Look for a way to either separate some things out, solve one that's fast, real easy, right, or solve an easy one real fast, and substitute it in, something. Because I don't want you solving 3 equations, 3 unknowns, 4 equations, 4 unknowns. And on a final exam, where how much work have we already done? Yeah, you ain't got time for that. So what we're going to do is we're going to say this is negative 3 plus 3b plus c. I took this first one and just put negative 1 in for a. Okay, we have negative 4 minus 2b plus 2c is equal to 0. Okay, so what we have is 3b plus c is equal to 4, and then over here we have negative 2b plus 2c is equal to 4. All right. Now you've got a system of two equations, two unknowns. There's enough ways to solve that for one for every day of the week, two on Sunday. Okay. Let's go ahead and multiply this equation by negative 2, negative 6b. By the way, don't worry, if you only know like elimination and substitution, that's fine. Okay. When you take linear algebra, you'll learn all sorts of other fancy ways to do this. Oops, this is a 4. And we're just going to add them. Okay, so we multiply by negative 2, we get negative 6b, negative 2c, negative 8. Leave this one alone, add them. Notice the c's fall away. So we have negative 8b is equal to negative 8 plus 4, so that's negative 4. And b would be, looks like a half. Okay. Pick either one of these two, right, to substitute b in. Since this one, right, has an even number next to it, and b is a half, I'm going to go ahead and plug it into the second one. So this is going to be negative 2 times a half, that's b, right? Plus, what did we say c was? We said c was plus 2c, or no, yes, plus 2c is equal to 4. Because negative 1 plus 2c is negative 1, okay, equals 4. 2c is equal to 5. C is equal to 5 halves. All right. So our partial fraction decomposition, right? Do you remember what you set up at the beginning? I don't. So we have a, b over x plus 2, c over 3x minus 2. So this is going to be, this is equal to 1 half, 1 over x. No, what was a? It was negative 1, wasn't it? Yep, sure was. So we have, change that. Negative 1. You don't need to put the 1. Plus, but what was b? B was a half, and this was 1 over x plus 2, and then plus 5 halves over 1 over 3x minus 2. Okay. You could write, I like to write it this way because I like to put the coefficients out in front, but it means the same thing to do this. I just think this looks messier, so, you know, I'm looking at this from doing calculus on it because that's always going to be the next step here, and I find it easier to integrate functions that look like this rather than functions that look like that. It's just a thing. I don't see these as quickly, whereas this is easy. I know it's the same thing, but you know, there you are. All right, so that what is that? That was number 7. That was number 7. So let's go ahead and stop this one, and then I will be right back with the next one. All right.